Name of subject, internal combustion engines. Name of chapter, introduction. Name of the topic, working of two-stroke engines. Contents, working of two-stroke SI engines. Dear friends, in the last few lectures, we already started to discuss the things about the internal combustion engines. In the last lecture, we discussed about the working principle of four-stroke SI and CI engine. Now today, we are going to discuss about two-stroke SI engine. Specifically, this particular two-stroke engine is available for spark ignition engine itself. Now with the help of these two diagrams, today we are going to discuss everything about the two-stroke engine. So I think all of you are knowing about the different vehicles like MAT. Okay, right now it is not available in the market, but before 10 years back that was available in the market. MAT, then Luna TFR. Okay, so if you remember, that particular vehicles or that particular two-wheeler has an engine, and that is nothing but the two-stroke engine. Okay, so with the help of these diagrams, here we are going to understand the working principle of two-stroke engine. So again, the parts are very much same, very much similar like four-stroke engine. Here we have a piston, connecting rod, crankshaft. Again, one more thing which is present over here, this is a crankcase. Okay, again spark plug is present over here. But if you observed in this diagram, the walls are present over in the case of four-stroke engine, but in the case of two-stroke engine, the walls are replaced by the ports. Okay, in the case of four-stroke engine, there is a use of walls, inlet wall and exhaust wall, but in the case of two-stroke engine, the walls are replaced by the ports. This is the basic fundamental difference between two-stroke engine and four-stroke engine. Now in the case of two-stroke engine, here we have three kinds of ports. One is a exhaust port. Here is a exhaust port. Please concentrate on the mouse indicator. Here I am showing. This is the exhaust port through which the exhaust gases will goes out to the atmosphere. This is the inlet port. We can see over here in this another diagram. This is the inlet port through which the amount of air and fuel mixture will come inside the engine cylinder, and another port which is present over here, which is an integral part of the body of the engine, and this is called a transfer port through which the fresh air fuel mixture charge can transfer and it will come above the piston area. Okay, so these are the three ports: transfer port, inlet port and exhaust port. Okay, so the construction is very much same as when we compared with this four-stroke engine. Piston is there, connecting rod is there, crankshaft is there, crankcase is there, where these all things are assembled together, and the three ports: inlet, exhaust and transfer port, along with one spark plug. Okay, this is a general assembly of two-stroke engine. Again, this is the cut section model of two-stroke engine. As we already discussed about the four-stroke engine, this is the cut section model of two-stroke engine. Okay, to understand the working principle of two-stroke engine, here we have to consider a few things. Always remember, my dear friends, in the case of two-stroke engine, there is only one revolution of the crankshaft. In the case of four-stroke engine, there are 4 stroke of the piston and 2 revolution of the crankshaft, but in the case of two-stroke engine, there is a 2 stroke of the piston and only single or 1 revolution of the crankshaft. Means for complete process of two-stroke engine, crankshaft will rotate at only one time, means only in 360-degree rotation of the crankshaft, and during this 360-degree rotation cycle, piston reciprocates 2 times. BDC to TDC and again TDC to BDC. Within these 2 strokes, the 4 processes: suction, compression, expansion and exhaust has been simultaneously happened inside the two-stroke engine. So we have to understand how this suction, compression happens simultaneously and expansion, exhaust will happen simultaneously within 1 revolution of the crankshaft and only 2 stroke of the piston. That is very important. Okay, so here we have 2 diagrams, 2 cut section models of two-stroke engine. with the help of this, we are going to understand the working principle of two-stroke SI engine. Why it is called as the SI engine? Because we are using spark ignition, we are using spark plug, as well as we are using petrol as a fuel. That's why it is called as a spark ignition two-stroke engine or two-stroke SI engine. Let us assume few things before going to understand the working of two-stroke engine. Okay, let us consider, yes, please concentrate on my statement, whatever I am telling now. Please consider earlier stroke some amount of air fuel mixture is present inside the engine cylinder. Look at the right hand diagram. The another diagram, please look at this right hand diagram. What I am telling to you, please consider earlier strokes some amount of air fuel mixture already present inside the engine cylinder. Okay, means again, if engine started and because of its earlier stroke, some amount of air fuel mixture is remain present inside the engine cylinder. Let us consider and look at the another diagram. Look at this right side diagram. Okay, now initially again when you are going to apply some pressure on the kick, if you can take the example of two-wheeler, again the engine crankshaft is connected to the foot lever, that is nothing but the kick of a particular vehicle. When you are going to apply some pressure force on that kick, this crankshaft will start to rotate. Suppose this crankshaft will start to rotate and connecting rod, because of the connecting rod, piston will start to reciprocate inside the engine cylinder. Okay, but in this case, in the case of four-stroke engine, what happened? Piston traveling from TDC to BDC for the suction process. But in the case of two-stroke engine, piston is not traveling initially from top dead center to bottom dead center. It always travels from bottom dead center to top dead center. Please remember. The initial position of the piston, again look at this left diagram. The initial position of the piston is at bottom dead center position. Now this inlet port is open. Okay, initially this inlet port is open and this transfer port is inlet port is remain closed and this transfer port is remain open and exhaust port is also remain open. Okay, this is initially. So initially what happened? Piston is moving from, again concentrate on the right side diagram. Initially when the piston is moving from this bottom dead center to top dead center, see the direction of motion of the piston. That time what happened? Please concentrate. The vacuum created below this particular piston area inside this crankcase. Please remember whatever I am telling right now. This is a very important concept. Okay, what I am telling to you, during piston moving from BDC to TDC, that time through the inlet port, the amount of air and fuel mixture will come inside the engine cylinder below the piston surface inside the crankcase. This will not happen in the case of four-stroke. What happened in the case of four-stroke? During suction, piston will move from TDC to BDC and amount of air fuel mixture will insert above the piston. But here, this is totally different one. Reverse things are happening in the case of two-stroke engine. During suction, when the piston is moving from initially BDC to TDC, this inlet port will open. Okay, if you see in the diagram, this inlet port is closed, but when this piston is moving from bottom to top, if you see in this diagram, here we can understand from the bottom to top, this piston discovers this inlet port and inlet port will remain open, and during this position of the inlet port, the external air fuel mixture will come inside the engine cylinder and it will come inside the crankcase. That is very important. It will come inside the crankcase. And sorry, and at the same time, the suction process is happening, and simultaneously, as I told you earlier, we already considered the earlier strokes air fuel mixtures present inside the engine cylinder that will get compresses because of the piston movement from BDC to TDC. Means, my dear friends, here we can understand suction and compression done simultaneously within only 180-degree revolution of the crankshaft, or half rotation of the crankshaft, and within only one stroke of the piston. I think you understood. Okay, means initially when the piston is moving from bottom to top, that time suction will happen, that air fuel mixture will come inside the crankcase, and at the same time, as we already consider, the earlier stroke air fuel mixture which is already present inside the combustion chamber of the engine, it will get compresses because of the piston movement. So we can say suction and compression will happen simultaneously inside the two-stroke engine, and similarly at the end of the compression stroke, spark plug provides the spark. If you see, during compression, this inlet port remain open, this transfer port it should remain closed, and exhaust port should remain closed. Once spark plug provides the spark, again the combustion process will start to take place. The earlier stroke air fuel mixture, whatever present inside the engine cylinder, it will start to burn, and its gaseous pressure is again coming on the piston crown. The specific shape of the piston is nothing but called as the piston crown. And if you see in this left diagram, because of the gaseous pressure, again piston will move from TDC to BDC. See the direction, the piston will move from TDC. The position of the piston during compression is TDC, but now the piston will move from TDC to BDC, and this process is nothing but called as a power stroke or expansion stroke. And during the same time, the earlier strokes, because of earlier suction stroke, the air fuel mixture, whatever amount of air fuel mixture which present inside this particular crankcase, this pressure of piston acts on this fresh charge, and it will move from the transfer port, and it will come up above the piston area inside the combustion chamber. Now what this particular fresh charge does, this will push the gases which present inside the combustion chamber to goes out, and this process is nothing but called as the exhaust process. Means we can say the power or expansion stroke and the exhaust stroke will happen simultaneously within next 180-degree rotation of the crankshaft and next stroke of the piston. Means suction and compression will done in one stroke, and expansion and exhaust will done in second stroke. That's why it is called as a two-stroke engine, and this cycle of operation will happen only a single revolution, that is 360-degree rotation of the crankshaft. Okay, so might have you have some question in your mind how that particular fresh charge will push that gases out. So my dear friends, always remember the fresh air fuel mixture density is always greater than the density of exhaust gases. Now in this case, what happens, as spark plug produces the spark, combustion will start to take place, burning will start to take place. Means that air fuel will get converted into gaseous form. Exhaust gases will be generated inside this particular chamber, and that exhaust gases pressure will act on the piston surface or piston crown, and because of that pressure, piston move from TDC to BDC, and it has a very low density, very less density. That's why as the transfer port open, this fresh charge will move upward, because the bottom surface of piston acts, bottom surface pressure of the piston acts on this particular air fuel mixture, fresh air fuel mixture which is present inside the crankcase, and that will move upward direction through the transfer port above the piston, and this fresh charge pushes gases out to the exhaust port to the atmosphere, and this process is nothing but called as the process of scavenging. Always remember, see, this fresh charge pushes exhaust gases out to the atmosphere. This process is called the process of scavenging. So I hope you understood this working principle of two-stroke engine. Again, with the help of the different video, different animations, we are going to understand the things, whatever things we learn up to this particular point: four-stroke engine, two-stroke engine, engine components, engine working, the different things now we are going to understand with the help of animations. Okay, so whatever things we discussed, we learned theoretically with the help of few videos. Whatever things or whatever doubts in your mind, it will get clear with the help of all the next kind of videos which we are going to watch now. Okay, so initially we start with the animation or animated video of two-stroke engine. Whatever things which I just discussed, now you will get more understand with the help of these videos. Yes.
While the four-stroke has to make 2 complete revolutions to produce a power stroke, the two-stroke engine only has to rotate once. This gives the two-stroke engine an advantage in acceleration and throttle response. Two-stroke engines are much simpler than four-strokes. Reed valves are small and lightweight. They don't need any mechanical linkage to make them open and close, since the pressure inside the crankcase does that quite well. On four-stroke engines, the valves are held closed by springs. A camshaft driven by the crankshaft opens the valves at the correct time. All of these parts add weight and take up space, so the two-stroke enjoys a significant advantage when you need a lot of power in a small, lightweight package. However, the four-stroke theoretically has the edge in fuel economy. The two-stroke is hampered because the intake and exhaust ports are...
Yes. So, please understand the things with the help of this video. Again, here we have the crankcase. This is piston, this is connecting rod, and here is the crankshaft. This port is the inlet port, this port is the transfer port, and this is the exhaust port. Okay, and here is the spark plug. Now let us consider this particular red portion is nothing but the exhaust gases, and the yellow particles is nothing but called as a fresh charge, which will come inside the engine cylinder. Okay, so initially what happened, as I told you earlier, when the piston will move from bottom to top, during suction process, the air fuel mixture will come inside the crankcase, means in this area, and at the same time the earlier stroke air fuel mixture, whatever present here, it will get compresses. Mean this is suction and compression happening in simultaneous way. And similarly, at the end of compression stroke, this spark plug provides the spark inside the engine cylinder. Piston will again move from TDC to BDC, and this transfer port will open. This yellow particle, means fresh charge, again moves up, and this pushes the exhaust gases out to the cylinder. This is called the scavenging process. Okay, now please see the video, watch carefully, you will get understand.
Open at the same time. This process is called scavenging, and we'll come back to it in a moment. The problem is that some of the exhaust gases get left behind in the cylinder, while some of the air-fuel mix gets blown right through the cylinder into the exhaust system without ever being burned. This wastes fuel and increases hydrocarbon emissions. On a four-stroke, the valves prevent the air-fuel mix from escaping out the exhaust, so the engine runs cleaner and uses less fuel. However, there's a better solution for two-strokes: Evinrude's direct injection. These models don't have a carburetor. Instead of an air-fuel mix, they cycle only air through the crankcase, and fuel is injected directly into the cylinder. The injection is precisely timed, so none of the fuel escapes out the exhaust port. This dramatically increases fuel economy and reduces emissions. Direct injection models enjoy all the performance advantages of two-stroke engines, yet they are equal to or superior in fuel economy and emissions when compared to many four-strokes.
Hope you understood with the help of this particular video, two-stroke engine. So Today we will see few more videos and it will beneficial for all of you to understand the engine working, construction, everything. Watch one by one.
We're going to explore some technologies that Toyota uses to maximize engine performance and economy and reduce emissions. First, we'll review the basics of how an engine works and some basic engine terminology. An internal combustion engine needs air and fuel to function. The more efficiently an engine breathes, the more efficiently it will produce power. Now we'll look at the basic components of an engine. The main components of the engine are the engine block and cylinder head. The internal components of an engine include cylinders, the crankshaft, connecting rods, pistons, spark plugs, fuel injectors, intake and exhaust valves, camshafts, and a timing chain or belt. Power is produced in the engine by the four-stroke process. As the piston moves on its first downward stroke, the intake valve opens to allow a mixture of air and fuel to fill the combustion chamber. This is called the intake stroke. Next, the intake valve closes and the piston moves on an upward stroke that compresses the air-fuel mixture. The compression of the air-fuel mixture will make it combust with greater force than if it were uncompressed. This is called the compression stroke. Third, the spark plug ignites the air-fuel mixture, causing it to burn explosively, which forces the piston into another downward stroke. This is called the power stroke. The fourth stroke is the exhaust stroke. As the piston begins its second upward stroke, the exhaust valve opens and the burned air-fuel mixture is forced out of the combustion chamber through the exhaust valves. Two terms you may be asked to explain to customers are the engine's compression ratio and displacement. Compression ratio is the ratio between the total volume of a combustion chamber and cylinder when the piston is at the bottom of its stroke and when the piston is at the top of its stroke. In this example, the compression ratio is 10:1. Higher compression ratios produce more power but require higher octane fuel than engines with lower compression ratios. Engine displacement is how the internal size of an engine is described. It's measured as the cylinder bore times the length of the piston stroke. This is multiplied by the total number of cylinders and is usually expressed in liters or cubic centimeters. For example, a 2.4-liter four-cylinder engine has a total displacement when adding together all four cylinders of 2.4 liters. The number of valves that engines have varies. Older engines tend to have one intake and one exhaust valve. Some engines have two intake and one exhaust valve. Most high-performance engines use two intake and two exhaust valves. The opening and closing of the valves is performed by the camshaft. Some engines use one camshaft with rocker arms and/or push rods actuating all of the valves. If the camshaft is above the valves, it's called a single overhead camshaft or SOHC engine. When an engine uses a separate camshaft for the intake and exhaust valves mounted above the valves, this design is called double overhead camshafts or DOHC. All Toyota engines use double overhead camshafts. Most four-cylinder engines, including all Toyota four-cylinder engines, are an inline design. Engines with more than four cylinders typically have the cylinders arranged in a V configuration. All Toyota 6- and 8-cylinder engines are V-type engines. Now let's look at technologies Toyota uses in its engines to enhance power output, fuel economy, and emissions control. The more efficiently an engine breathes, the more efficiently it will produce power. Toyota engines incorporate a number of features and components that are designed to help the engine breathe more efficiently. An acoustic control induction system, or ACIS, automatically varies the length of the runners in the intake manifold to maximize the airflow into the engine and to provide more usable power throughout the entire RPM range. At low speeds, ACIS directs intake airflow through a long intake runner in order to produce ample low-end power and torque. Think of this as taking deep breaths while lifting a heavy object. At high engine speeds, ACIS directs the air through a short intake runner in order to generate more horsepower. Think of this as taking quick short breaths while running. Some manufacturers utilize a single overhead or SOHC engine. All Toyotas feature double overhead cam or DOHC engines that allow optimum placement of the valves. Benefits of a DOHC design includes enhanced power output, fuel economy, and emissions control. Since the power of an engine is determined by how much air and fuel can be burned in a given period of time, Toyota uses 4 valves per cylinder instead of 2 or 3. This arrangement improves the intake and exhaust performance of the engine over other valve configurations. A 24-valve engine would be a 6-cylinder engine with 4 valves per cylinder. Variable valve timing with intelligence, or VVT-I, is one reason why Toyota cars and trucks develop horsepower and torque across a broad RPM range or power band. A computerized system changes the intake valve timing to optimize the engine's breathing depending on the conditions. Without VVT-I, valve timing is fixed no matter how fast the engine is turning. As a result, an engine that works well at high speeds won't perform as well at low speed and vice versa. With VVT-I, intake valve timing is constantly adjusted, enabling the engine to perform well over a wide range of speeds. For an even greater range of valve control, some Toyota engines use dual independent VVT-I, which controls both the intake and exhaust camshafts independently of each other. This provides an even greater range of valve control. Double overhead camshafts makes it possible to independently control the intake and exhaust valves. This results in enhanced power and torque delivery and greater fuel economy throughout the vehicle's power band. A dual-path exhaust system works somewhat like ACIS, except ACIS maximizes airflow into the engine, while the dual-path exhaust maximizes exhaust flow out of the engine. A second path or chamber opens in the exhaust system at higher RPM to help evacuate the higher volume of exhaust, resulting in better breathing with less back pressure.
Yes, with the help of this video, you understood how the recent technologies are present in the market and how the development in the internal combustion engines are going on. Okay, so please watch this another video. This is again very much helpful to understand the scenario
This is
of
an
IC engine.
introductory lesson on how a gasoline engine works. Here, you can see the main components of the internal combustion engine. From the top left, we have the valves. The valves open and close to let gas and air in, as well as letting exhaust out once the gas is burned. Next, to the right, you can see the camshaft. The camshaft has little oblong-shaped circles on it that are called lobes. And as this shaft turns, the lobes push open the valves to let the gas in and the exhaust fumes out. The cam turns because it is attached to the crankshaft below by the timing belt, but we'll talk about that more later. Here, you can see the camshaft turning and pushing the valves open and closed. The valves are attached by springs that you can't see in this animation. However, the springs return the valves back up to their starting position. But you can see the basic concept of how the camshaft with the lobes on the ends pushes the valves down as the oblong-shaped part of the circle comes around. Next is a distributor. The distributor takes electricity from the battery of your car and sends it to the spark plugs using wires. The spark plugs are small stick-shaped pieces of metal with a conductive material in the middle called an electrode. When the electricity reaches the end of the electrode, it wants to go somewhere, but it only has one option, and that is to jump the little gap at the end. When the electricity jumps, it is called a spark, just like how you use a spark to light a lighter. This is the distributor with the wires coming out of it going straight to the spark plugs. The spark plugs ignite, as you can see here, and ignite the fuel above the piston, which will be later explained in this video. Next is the piston. The piston goes up and down because above it there's an explosion, and we know that explosions are very powerful. So when the spark from the spark plug ignites the gas that is put in by the valves, it combusts and pushes the piston down with a lot of force. Next, we see the crankshaft. The crankshaft is a shaft with a lever shaft connected to it that is not in the center of the main shaft. This shaft converts the up-down motion of the piston to a rotary motion that turns the wheels on your car. Here, in the circles indicated, you can see the counterweights of the crankshaft. The counterweights make sure the shaft does a full circle and pushes the piston back up to get ready for the next explosion. Here, you can see the crankshaft and the pistons moving up and down together. Next, we have the alternator. The alternator is connected by a belt to the crankshaft, and as the crankshaft turns, it turns the alternator. The alternator charges the battery in the car so that it doesn't die quickly. Without an alternator, the battery in your car would die extremely fast due to the spark plug charges. The timing belt that connects the alternator and crankshaft and camshaft is just a belt so that they all run in unison. All in all, the motion of the entire system comes from the pistons moving up and down from the explosions inside. The pistons turn the crankshaft, and from there, using a belt and pulley system, the crank turns the alternator to charge the battery, and then the camshaft, which opens and closes the valves to let more gas in and exhaust out. Next, we will show the 4 strokes of the engine. Here, you can see all of the strokes of the engine. These are all the parts of the engine that were just explained, but more in detail. Next, you'll see the first stroke of the engine, the intake stroke. As the piston goes down, the valve opens and lets air and fuel in. Next is the compression stroke. As the piston goes up, it compresses the air and fuel. Now that it is compressed, it is ready for the explosion. The spark plug ignites, forcing the piston back down. The piston gets forced down here when the explosion happens, as you can see, and turns the crankshaft at the bottom. Now, the piston goes back up, and as the valve opens, it pushes all the exhaust gases out. Next, you see a full working engine. The
This
only
is the actual
difference
real
is
engine.
this engine is turned by a motor because we cannot have explosions with an open motor. This is a cutout of a Ford engine. Here you can see the piston, the valves, the springs. However, the camshaft is not visible. This is a spark plug with the wire removed. It sits inside so that the explosion can happen. That's another spark plug with the valves to the right. This is the working engine. The crankshaft, the yellow figure, is turning, and the pistons and their connecting rods are going up and down. The blue is the connecting rod on the bottom. Here you can see the valves opening. That is the fuel valve. That is the exhaust valve. Now from the main perspective, you can see all the engine's main working parts and how they work. This is the basic concept behind an engine.
I think this is again more useful video to understand the engine concept. So now this is about the working of two-stroke engine. Please watch this another
A
video.
two-stroke, or two-cycle, engine is a type of internal combustion engine which completes a power cycle in only one crankshaft revolution and with two strokes, or up and down movements, of the piston in comparison to a four-stroke engine, which uses four strokes. There are usually three ports, an inlet port, exhaust port, and a transfer port. The transfer port connects the lower chamber beneath the piston to the upper chamber above the piston. The first stroke of the two-stroke petrol engine begins with the piston about halfway down the cylinder heading toward the top of the cylinder, going upwards. Because the piston is halfway down the cylinder, all of the ports are covered. Because of the upwards motion of the piston, the bottom chamber below the piston falls below atmospheric pressure. As the piston moves closer to the top of the cylinder, it uncovers the inlet port, which then, because of the pressure in the lower chamber, sucks air and fuel into the lower chamber. The second stroke of the two-stroke engine is carrying on from the first stroke, which sucked the air into the lower chamber. The piston has nearly reached the top of the cylinder. Just before it does, the mixture of air and fuel in the upper chamber above the piston is ignited. The high pressure of the burnt gases forces the piston down. On the way down the cylinder, the piston recovers the inlet port, stopping any fuel/air from being sucked into the lower chamber. As the piston moves downwards, the mixture of air and fuel in the lower chamber is being compressed. When the piston gets to be DC, bottom dead center, the exhaust port is fully uncovered, which releases the burnt fuel in the upper chamber, and also draws fuel and air from the lower chamber through the transfer port into the upper chamber, ready for the next stroke. The first stroke of the two-stroke petrol engine begins with the piston about halfway down the cylinder heading toward the top of the cylinder, going upwards. Because the piston is halfway down the cylinder, all of the ports are covered. Because of the upwards motion of the piston, the bottom chamber below the piston falls below atmospheric pressure.
Yes, this is the working of two-stroke. So the main intention to show such kind of a videos, because right now you understood all the theoretical knowledge about the working principle of two-stroke, four-stroke, terminology of the engine, and whatever things we learned theoretically. And with the help of this video, if even you have some doubts in your mind, it will get cleared with the help of this particular video. That's why the intentionally I'm showing all this video. And again, with the help of such kind of videos, you will come to understand what the things are going in the world about the recent technologies in the engine. So the next videos, this would again very interesting to understand how the recent development is going on about the engine. We have some videos of Mercedes, Chevrolet, etc., etc. Okay, so please watch the videos. This is again very informative one. The engine block from Mercedes. Person is doing assembly. This is the such kind of oiling to reduce the friction. Now see, this is about the pistons. Very precise machining operations has performed on the different components of the engine. Lubrications are going on at the different components of the engine. The person is fitted the piston inside the cylinder. Electrical person is responsible for whole assembly of the engine. the work is going in the factory. Now this is for the drive. This is the chain drive mechanism. Now this is the kind of things which will be useful for the sealing purpose. This kind of a seal. In some engines, some companies are using some gaskets, metallic gaskets, rubber gaskets, or some companies are using such kind of a chemical seals like this. Will work as a leak proof. See how beautiful the engine is after the assembly. Now this is the main gasket which fitted on the cylinder head. The head above the cylinder. This is called the cylinder head. The camshaft for opening and closing of the valves. Double overheaded camshafts they are using. The two camshafts are there. So now the manifolds. Here is the complete assembled Mercedes engine. The logo is going to fit, and this person, single person, is responsible for the assembly. That is a handcrafted. His name is there, Mercedes AMG Germany. So hope you understand again the various concepts get cleared with the help of this video. This was very interesting one. Now this is about the Chevrolet. Now this is the V8 engine assembly. See, every company is having some specialty for manufacturing as well as for assembling of the engine, manufacturing the different components. If you see in the last video, the Mercedes design were different. Now this is the design of Chevrolet. Their design is different. So likewise, the things are going to change as per the company's policies, company's design. Okay, so see the beauty of this with the help of such kind of this kind of videos. See the design of crankshaft is different one over here. Chevrolet is one of the major company in US of engine manufacturer.
Yeah, it's pretty fun. I mean, we're I guess I could just say on this right here. Well,
Now see this assembly process is a different one. The walls mechanism. That is Chevrolet. Again, the mic priest, the person who is assembling this particular engine. Now see the manifolds. The design is totally different as compared with that Mercedes. is attaching the flywheel. See the automation part. See, while watching this video, it's not look like to understand the engine, but you must have to understand the automation, how the automations are going in the industry itself. And this is the finished car of General Motors V8 engine. So hope you like all these videos, and these are the videos which are very much useful to you to understand the different things about the engine and different technology in the market. And this would be the last video, and then we'll stop our today's session.
Today, the internal combustion engine is used in motorcycles, automobiles, boats, trucks, aircraft, ships, heavy-duty machinery and power generators. A four-stroke engine is an internal combustion engine in which the piston completes four separate strokes: intake, compression, power, and exhaust during two separate revolutions of the engine's crankshaft, and one single thermodynamic cycle. Let's take a look at the basic internal parts of a four-stroke engine. Inside the engine block, there is a crankshaft. Piston rods are attached to crankshaft. Pistons are attached to the piston's rods. As the crankshaft turns, it causes the lifter to make each piston move up and down. At the top of the crankshaft there is a camshaft which is connected to the crankshaft by a timing belt. While the crankshaft is making the pistons move up and down, the camshaft is turning, making the valves to open and close. Let's now take a look at how the combustion creates pistons motion. First, intake stroke. The inlet valve is opened, and the fuel-air mixture is drawn in, as the piston travels down. Second, compression stroke. The inlet valve is closed, and the piston travels back up the cylinder, compressing the fuel-air mixture. Just before piston reaches the top of its compression stroke, a spark plug emits a spark, to combust the fuel-air mixture. Third, combustion stroke. The piston is now forced down by the pressure wave of the combustion, of the fuel-air mixture. The engine's power is derived from this cycle. Fourth, exhaust stroke. The exhaust valve is opened, and the piston travels back up, expelling the exhaust gases through the exhaust valve. At the top of the stroke the exhaust valve is closed. This process is repeated. What had been presented is the cycle of operation of one cylinder of a four-stroke engine. Generally, engines have two or more cylinders acting in concert with each other to produce the engine power.
Okay, hope with the help of all this video you got a more clear idea about the engine and the things. The intention to show this all the videos to understand thoroughly the concept whatever we learn in our theory sessions, and these videos are again helpful to understand in well manner. So thank you so much. Today we are understood the two-stroke engine and working principle, as well as we discussed the different things, and with the help of that videos we could able to understand the things about the engine. So thank you so much for watching our today's session. Thanks a lot.